All right, so what we're going to go through here, this is important. This is probably your first exposure to what we call conjecture questions. So there's definitely going to be a conjecture question coming up in this test. And the Hazy textbook does not do a good job at providing conjecture questions. So we have supplemented them from previous exams. This is a booklet I've been generating for a couple of years now. And it starts with differential calculus conjecture questions. So there's about 15 of those, worked solutions on the OneDrive. And then following that, there will be some that pop up in integration. So this is a booklet that you will need to hang on to. And like first principles, they are long answer questions. And they really do illustrate the degree of complexity to which 12 methods will go to. So we're going to go through conjecture example 2. The reason I've chosen this one is because it's a little bit shorter and it's a little bit of an easier proof. Conjecture example 1, which is on the previous page in your notes book. So we're looking at our notes book, page 28. On the previous pages, I'm going to set that for homework. I've got a video of that recorded for you to fill in at home. So we will dabble in them in our notes book to get the exposure to them, and then it's up to you how you process them in the conjecture booklet that I've provided for you. You won't be able to answer all of the ones in the booklet yet because some of them are stationary points, some of them are points of inflection. So as we encounter them, I'll point out which questions you're capable of doing. Let's get straight into the question so we can demonstrate how it goes. So we have the function, consider the function f of x is x on x plus 1, and the graph is shown below. On the graph above, draw the tangent when x is 1. Okay, so you've got a graph, it looks like this. All right, here's an asymptote, and we're asked to draw a tangent here, just to the best of your ability, a straight line that touches at that point. So the tangent will look something like that. Okay, 1 mark. Now, any graphing questions in a test or an exam, you absolutely have to get them. They're easy marks to get, so make sure we get that. Okay, part B says, determine f dash of x. These conjecture questions will always start easily, and so we have to get the easy marks, and then they'll get progressively more complex, the harder marks are more challenging to get. So if we're going to differentiate this, we have to use the quotient rule. We've got u on top of v. U is x, u dash is 1, v is x plus 1, and v dash is 1. Smash it together, u dash v, take away u v dash, all on top of v squared, and we'll evaluate that. The derivative function, get yourself 2 marks there. Okay, hence show that the equation of the tangent to the curve at x is 1 is, and we're presented with an equation. So we're asked to find the tangent to the curve at x is 1, and it is in general form, which means we need to use a general form process. So that's part B, we're on to part C, and for part C we need the point of contact, and we're told the x value is 1, and when x is 1, the y value is going to be 1 on top of 1 plus 1. That's 1 on top of 2. All right, I'm just getting that straight from here. And the slope will be 1 on top of 1 plus 1 squared. So that's 1 on top of 2 squared. The slope is 1 on top of 4. Okay, so we can flick back to our notes on general form. I have slope of A on B. It's positive, so that means, so let's state it like this. AX take BY equals C. That's the form it's going to take. I'm going to have 1 lot of X, take 4 lots of Y, is equal to C. And in order to find C, I'm substituting one lot of the x value and then take away 4 lots of the y value. So x take 4y equals 1 take 2, x take 4y equals minus 1 QED. It has been demonstrated. Okay. So finding the line in general form, get ourselves 2 marks there. Part D, find the y-intercept of this tangent. Now, when a tangent's in general form, it's beautiful because it shows you the x-intercept. The x-intercept occurs when y is 0, the x-intercept is minus 1, and the y-intercept occurs when x is 0. So the y-intercept occurs when x is 0, we would have minus 4y equals minus 1. So this is for part D, find the y-intercept. Minus 4y is minus 1, which means y is minus 1 on minus 4, which is positive a quarter. The y-intercept is a quarter. Alright, so remember y-intercept occurs when x is 0. I have minus 4y equals minus 1. You solve that equation, you get y is positive a quarter. Good. Okay, so we're on to question E then. The equations of the tangent to the curve at points x is 2 and x is 3 is shown below. Use them to complete the table. So x is 1, this is the equation of the tangent, and we have the y-intercept of the tangent. We found that it was a quarter. Okay. Then we have this one, x take 9y equals minus 4, and we're saying, what's the y-intercept of this tangent? All right, so if you're going, all right, well that occurs when x is 0, I'd have minus 9y equals minus 4. So I would have y is positive 4 on 9. If you want, you can write it out in the extra working space. All right, and then for the last one, the y-intercept, okay, x is 0, minus 16y is minus 9. So I would have 9 on 16. Okay, fill it in, done. 2 marks there, all right? And so really, you've already got this from part E, and so you're getting the 2 marks for that, all right? 4 on 9, 9 on 16. So hopefully we're seeing, all right, we're getting those sort of easy marks. They're starting to get a little bit more complex. Now, let's have a read. Make a conjecture. Okay, that means an estimate. Based on the inductive evidence that we have here, what's going to be the y-intercept at x is a. So we're trying to draw a relationship between this number and this one here. X is 2, 4 on 9. X is 3, 9 on 16. Okay, now, it's not always clear what the conjecture is, but break it down. Can you see a relationship between the number and the top number? It's the square, isn't it? So if we have 3, 3 squared, 2, 2 squared, if I have a, then at the top I'm going to have a squared. Very good. And how about the bottom one? It's the next square number, isn't it? So if I've got 4, well the next square number is 9, you know, so 9 is 3 squared, the next square number is 4 squared, all right? And so what's going on here is whatever the a value is, it's the a value plus 1 squared, because it's the next square number. Now that second part is a little bit tricky to see, okay? And some of them will be a bit tricky to see. But we're going to develop this skill, right? It's not something I expect you to be able to do right now. Okay, very good. So let's explain what's going on here. This is the function. We drew the tangent at x is 1, and we saw it has a y-intercept of a quarter. Okay? Then we drew the tangent at x is 2. All right, I haven't drawn it very well, but we're saying what's the y-intercept of that tangent. Then we did the tangent at x is 3. Okay, and we can see the y value of the tangent is changing. And so we're coming up with a general form such that this tells you the y-intercept for any tangent, okay? That's what's going on here. We've made a conjecture, and now we're going to prove that it's true. Prove or disprove your conjecture. Okay, so what are we doing? We're finding the equation of a tangent at x is a, and we're finding the y-intercept of that tangent. Okay, that's what we've been doing. We need to find a tangent at x is a, and then find the y-intercept of that tangent. So, let's do it. For a tangent, we need two things. We need the point of contact. What's the x value? A. We're saying the tangent at x is a. So if x is a, then the y value, all right, the y value, the function we have is going to be a on top of a plus 1. We've got the point of contact. Okay, next we need the slope. Now we've already found the slope formula. We did it in part B. All right, and notice how it says 1 on top of x plus 1 squared. All we're doing is putting the a value there. So we're going to have 1 on top of a plus 1 squared. That's the slope. So we're just finding them, all we're doing is finding a tangent with these properties. This is the slope, this is the point of contact. Now, it has a positive slope, right? 1 lot of x on top of a plus 1 squared lots of y. So if I'm doing general form, okay? Remember, if we have 3 on 4, this is from our calculus notebook, where we're talking about general form. 3x take 4y equals c. That corresponds with this. This is my number of x's, this is my number of y's. So we will have 1 times x plus a plus 1 squared times y, okay? ax, by, sorry, that should be a negative, take. If the slope is positive, that becomes a take. Alright, so I've got my general form. All I'm doing is plugging those letters, because they're not really numbers, into the general form formula, and that's equal to c. Okay, so I can just write x, take a plus 1 squared y equals, and for the value of c, I've got 1 times the x value. And the x value is a, and then plus a plus 1 squared times the y value. The y value for point of contact. A on a plus 1. All right, let me break that down because that's quite a tricky step, okay, what we've done there. Remember, what I'm talking about here, this is the most complex 12 methods we'll get, okay, so don't be alarmed. We're going to develop these skills. We're finding the tangent at x is a. We've got the point of contact. We've got the slope, all right? And then I've just taken the slope into the general form equation. ax take by equals c. Then in my next step, all I've done is plug the point of contact in. I'm putting the x value where x is, the y value where y is. Now we're just going to evaluate this. That's all we're doing here. So on the left-hand side, that stays the same. On the right-hand side, I'm going to have a plus, now I'm looking here, a plus 1 squared at the top, a plus 1 at the bottom. That can cancel, and the power can cancel, right? The same thing at the top, same thing at the bottom. And so we're just left with at the top, a times a plus 1.
Mr. Ross, it should be a minus square for the c value.
Thank you.
Yeah.
We'll pick up. A plus 1 squared y equals, and this will be a take a squared take a. All right, I'm just distributing that a. A take a cancels. And so this is the equation for any tangent drawn at x is a. Alright, so we've got 3 marks so far. Pretty challenging. However, we're asked to find the y-intercept of this tangent. The y-intercept occurs when x is 0. Alright, so we would have minus a plus 1 squared y equals minus a squared. Divide both sides by minus a plus 1 squared. Negative at the top, negative at the bottom cancels. QED. That was our conjecture. We have demonstrated it is true. Alright, that the y-intercept for the tangent at x is a for any value has this equation. Alright, we've got a minute. I'll just take you through it again. What do we do? We recognise the conjecture, we develop it. Okay? We find the point of contact, we find the slope, general form for the slope, plugged in the coordinates, evaluate, okay? That's the tangent. And then, y-intercept when x is 0, solve for y. That was our conjecture. Okay, really good. So, just to be very clear about what's in the week of homework, I will send an email about this. Okay, so our next lesson is Friday. Want you to complete as much of 3A as you can. I've got a YouTube video that goes through conjecture example 1. Alright, so do that after you've done a bit of 3A. Conjecture example 1's on page 26 in your notebook. Okay, in your notebook. I wouldn't have a look at the conjecture booklet just yet. Just do the ones in your notebook for now. And I'll send through a test reflection as well, so you can provide some feedback on that. You can now access the solutions. Okay? Alright, very good. Have a wonderful afternoon, and we'll catch you all on